the global warming potential, so the impact to the climate of the refrigerants that are used to power a standard air conditioning or refrigeration system are at minimum thousands of times higher global warming potential than carbon dioxide. When it fails, when it leaks. This is not constant, right? This occurs only when there's a damage or a break in the system. But it's thousands of times more detrimental on a volumetric basis.
Now, we've covered a few different approaches to addressing the climate crisis here. Minimizing plastics and waste, encouraging better behavior, and there's no one magic bullet to this existential problem. Solving the climate crisis is going to take many different solutions for hundreds of challenges. Now, we take a look at what role material science will play in solving the climate crisis, spoiler, making those ACs run more efficiently and avoiding critical failures that leak harmful refrigerants. This week on Big Feet, why your air conditioner sucks and what it's going to take to improve this 100-year-old technology. To help me out with that, Liam Berryman. First off, thank you so much for coming onto the show. So there's a lot of different ways that material science is going to play in the climate crisis, air conditioning just being one of the ones that you're working on. Before we dive into that, could you tell us a little bit about yourself and the company that you're building?
Sure. Happy to. First of all, very pleased to be on the show. I appreciate you guys having me on. So my name's Liam Berryman. By background, I'm a chemical engineer, but for the past approximately 4 years, actually close to 5 at this point, I've been building the company Nalumbo. Nalumbo is a materials company. We focus on bringing the world's first low-cost, highly scalable, and environmentally compliant platform for applying nanostructure to surfaces to a variety of different products, many of which you use in your daily life. So our first product line is in the cooling industry for air conditioning and refrigeration equipment, where we're using this nanostructure to solve problems like frost and ice in low temperature systems, corrosion in outdoor systems, and water accumulation and mold for your standard air conditioner.
Mm-hmm.
And what this does is it increases energy efficiency and increases the longevity, so how long this equipment can last in the field. One of the new product lines we're working on is on more flexible substrates like nylon, which is something that you should be hearing a little bit more about later this year. But the basics of us as a company is we develop the materials and we bring in strategic partners that bring manufacturing and distribution channels for existing products. We work together to develop a product that integrates in nanostructure typically for the very first time. So we're almost always a first mover in these product lines that we're entering. And then we go to market with those particular partners.
So diving back into the field of materials engineering, what would you say is the importance of material engineering in the climate crisis? So looking at the role you're playing at Nalumbo, how would you describe the approach you're taking to attack climate change?
Yeah, that's a really good question. So if you think about it, there's two big ways that materials can contribute to or change the products that are around us. So one is by enabling those products to do something they can't currently do, to bringing in a new capability or a higher level of performance that currently exists.
Mm-hmm.
And then the second reason is that it simply is what the product itself is made out of. So it's after the product is no longer being used, it's what still exists in our environment, whether it's recycled or we put into landfill or dissolved or gasified or whatever other means we use to get rid of it. The materials are what the product is. That's what it's made out of at the end of the day. And so there's a really cool opportunity where if you get the material science right and you really make something where the chemistry itself, what it is, the composition of it is not detrimental to the environment. It easily dissolves, or it's easily recycled, or it's something that is very minimal in terms of impact to landfill. It's something that unlike, for example, a lot of fluorinated chemistries, they wear off into the environment and start becoming bioaccumulatory, so they become toxic to plants and animals. You can create chemistries that don't do things like that and also improve the performance or bring a new capability to a product because it's something that hasn't been possible before. Then you kind of get two for one. is how I see it. So I
Gotcha.
see that is a big part of our role looking at the materials of things. Is it's asking, what's not possible today that we think we can do, and can we do it with materials that at the end of the day are going to be at least neutral, if not, very positive on a net basis to what's left behind when this product is discarded or no longer used.
Okay, yeah. So it's changing products so they last longer and are actually recyclable and maybe made out of more sustainable materials.
Mm-hmm.
And I know more and more companies are moving towards more sustainable products with those types of qualities. And you're part of helping companies actually achieve that, right?
Yeah, I mean that's a big part of our goal at Nilembo is every product that we work on, we're not only increasing the economic value of that product by bringing it a new capability it hasn't had before or a threshold of performance that it
Mhm.
just simply hasn't seen before. We're also, in some manner, increasing the environmental sustainability of that product, and that's through both indirect and direct means and direct means. Directly, we actually contribute to a reduction, again, in the case of our first product line, a reduction in the amount of carbon dioxide equivalent emissions that occur through preventing acute failure of heat exchangers in cooling devices, which cause very harmful refrigerants to leak into the atmosphere.
Mhm.
So that's one direct way we can contribute to reducing the amount of carbon equivalent emissions.
Mhm.
And then an indirect method, but still very important, is simply making the devices we use much more energy efficient. Allows us to, in the consumption and in the generation of cool or in cooling down air or other fluids, use less energy in that process. So for the
Mhm.
equivalent amount of cooling, using less energy, you're indirectly going back to where that energy was produced, reducing the amount of emissions that are generated.
Yeah. So I guess just going, I know a lot of your guys' work has been on HAC sort of HVAC systems, um, which depending on where we are and where you live for climate change, you might be using a lot of. I know I lived in LA all last year and I was using my AC a lot, and so I have an AC. I mean, what's wrong with it?
It's a good question. In basic form, there's not something that's wrong with the system per se, right? It fills the function that you need as a consumer.
Mhm.
It takes air from the outside and it cools it down to a certain temperature set point so that you can experience a more comfortable indoor climate. I mean,
Mhm.
that's the basic function of an air conditioner. And then a refrigerator or freezer system is effectively the same product, the same system that just goes to a much lower set point.
Mhm.
The challenge, though, is that, and this is what's pretty unknown to most consumers, is that as you're operating these systems, the components that drive that operation during the process of cooling air actually have a lot of different surface challenges that occur, similar to things that I listed earlier. So things like the accumulation of water. This is what happens when you cool down very humid air. You take water vapor and it condenses into liquid water, very similar to what happens on the outside of a drinking glass of water that's gotten too cold.
Mhm.
That causes problems for your system. It decreases its energy efficiency. It causes the buildup of mold and other contaminants, which are further detrimental to the system. And then over time, you also have the deposition of contaminants in the system on these components that are operating to cool air, which further decreases efficiency and leads to these problems like leaks that cause catastrophic failure of the system and ultimately a huge amount of very high global warming potential refrigerant being leaked into the atmosphere. And so, all of that is not something that's obviously advertised by the companies that are producing these systems, but they're very real problems.
Hmm.
And the big challenge is that the air conditioning system itself is actually a pretty darn mature technology, right? It's been around for 100 plus years. And so the challenge is in a mature industry that's very cost competitive, you have to find ways to increase performance or increase energy efficiency or longevity of a system at a very favorable cost point. We think of this as the performance versus cost trade off. And so it's actually pretty difficult to do that with a lot of the existing mechanical design differences that you can go after. So, what we see our approach as is by bringing a material, a nanostructured coating, if you will, to certain components in the system.
Mhm.
We're using low cost chemical inputs to create ultimately a difference in energy efficiency for the system. So we view our performance versus cost trade off in this particular product application as highly favorable. And that's one of the advantages that we bring.
Probably not a very efficient one.
Yeah.
That harmful? Like
Yeah.
what are we
So
looking at?
yeah, without going into the chemistry details, because that'd be a longer conversation.
Mhm.
The basics to understand are that the global warming potential, so the impact to the climate, um, of the refrigerants that are used to power a standard air conditioning or refrigeration system are at minimum thousands of times higher global warming potential than carbon dioxide.
Whoa.
Now, there's much more carbon dioxide produced than on a volumetric basis and emitted into the atmosphere per year
Mm,
than the refrigerants that exist in these systems, but it's a non-negligible number.
yeah.
So every unit, if you just think about equivalent amounts of carbon dioxide
Mhm.
versus the stuff that's in your air conditioner, if you just emit 1 unit of each of those at the same time, you're actually doing thousands of times more impact from the stuff that's coming out of your air conditioner when it fails, when it leaks. This is not constant, right?
Mhm.
This occurs only when there's a damage or a break in the system.
Mhm.
But it's thousands of times more detrimental on a volumetric basis.
Gotcha. And it seems like it's a possibly pretty significant amount. And I don't know about you, but I was never up on the roof of my apartment to see what the AC was looking like and if it was in the right shape. I don't know about the management if they were actually taking a peek on that. But are a lot of these being run with some sort of damage in there that are releasing these chemicals where like it is a solid problem?
So it's actually designed into a standard air conditioner
Really?
that a given pretty significant quantity of the refrigerants will leak out
Huh.
year after
It's
year.
designed into it.
Yeah, it's part of the design. It's not supposed to happen, right? The idea is it for it to not happen,
Uh huh.
but the assumption is that
Mm,
just due to field conditions, just due to machines aren't perfect,
yeah.
basically, there will be some leakage of refrigerant. So a standard air conditioner, even after it's lost a pretty big amount of the refrigerant that was put into it initially when the system was first created, um, it can still operate with a much lower amount of refrigerant. It's not as efficient, but it can still operate.
Okay, so they put more than they
But
need into
so
it, knowing some of it's going to leak
yeah,
out probably. Okay.
correct. And then like another factor is sometimes it's not even the system itself that it isn't working well. It's just that when routine maintenance is done, like a contractor or someone that's providing mechanical services, sometimes there will be a leak of refrigerant out that they don't replace when they are just adjusting the system,
Hmm.
and that's not necessarily anybody's fault. That's just the kind of the way these systems work.
Gotcha.
So that's already there. If you've lost all of the refrigerant system, you have a catastrophic failure because you can't operate a cooling system without that refrigerant. It's
Okay.
just simply not possible. So your system actually shuts off, and that's when someone will pick up, a consumer will pick up the phone and call, their service company or their
Hmm.
or their maintenance contract company, and say, my air conditioner is not working. But most don't have knowledge that that's because of this particular problem. It's to them, it's just not providing the service that they want to see from your a standard air conditioner.
Wow.
But the question, the answer to your question is that this is the direction that things are moving. I think we need them to move this direction more quickly. But like there was the Montreal Protocol,
Hmm.
and then the Kigali Amendment to the Montreal Protocol, which are agreements that many countries and the air conditioning industry actually have signed on to going forward with, which account for designing new cooling systems that are able to run on refrigerants that are less environmentally detrimental than what the current state of the market is, state of the art is.
Even right now.
Those redesigns, yes, even right now. So there's basically this roadmap in the industry of, by 2023, people need to be selling systems that are using a different refrigerant than what's sold today. which means you need to design your system differently because there's different thermodynamics, there's different mechanics basically that need to go into how these cooling systems are designed and operated if the working fluid, the refrigerant, is a different chemistry. So
Gotcha.
we're moving in the right direction, but it's that's just for new sales. That's not going to account for the existing installed base of cooling devices. So you're not going to see like an instant switch from an old refrigerant to a newer refrigerant, and this it'll happen over time, but it's not a cure all. I'm not saying that there is anything that can be a cure all, but we definitely need to be moving in the direction of better refrigerants and then just devices that use less energy as they operate as quickly as possible, because cooling is one of the runaway issues that we see with the climate challenge. It's already a huge fraction of use. It's continuing to grow based on demand from consumers and businesses. And as the planet gets warmer in different environments, cooling becomes the thing you need in order to continue making people and businesses operate. So it could be an exponential problem. That's the fear that a lot of people have.
Gotcha. So you guys are trying to, I guess, mitigate that exponential problem by trying to eliminate it as a problem, it sounds like, right? By making it so that these don't break down and don't release these refrigerants into the air to begin with, right?
Yeah, that's correct. And we are one solution amongst a number of different approaches. And ultimately, to really solve the cooling piece of the overall climate challenge is how I think of it. There will be multiple different solutions that'll have to actually be implemented and work together. So that there really isn't a single cure-all. What we're doing at Nelumbo has a huge impact and is great for the industry because it's a solid performance versus cost trade-off, which is hard to find elsewhere. But we are, by no means the only solution or the only thing that you should be implementing in a cooling system in order for us all to move towards a more sustainable future.
Gotcha. And there's less damaging coolant for newer heat pumps. So, like purchasing a new heat pump or something that's new on the market right now would theoretically be better, at least than an older one, right?
Yep, that is right. That is right. But there is still nobody on the market today except for our company. So this is a little bit of our shameless plug for the day. There's nobody on the market today that is offering a solution to the acute failure for heat pumps that I was talking about before, where you have corrosion leading to a significant leak, which means all the refrigerant escapes your system and your system shuts down. So that's actually something I know is being discussed within California right now, is how can that problem be solved?
Yeah, no, it shouldn't be acceptable that refrigerant is able to leak out into the air and damage the environment.
Exactly. Right. So it's like if you transition from existing means to using heat pumps, you're gonna reduce the amount of energy that's being used because heat pumps are more efficient. But if you then leak all that refrigerant into the atmosphere, because this system, compared to a hot water heater or other method for your house, because this system, leaks refrigerant in the atmosphere, you're going to basically lose all of the carbon dioxide on a net basis. You're not going to actually gain anything in terms of defeating emissions.
Which is why
So
you guys
you've
are
got to find a
focusing
way to
on
solve
that
that
part
problem.
and that
Yeah,
solution.
that's one of the reasons. Exactly. That's right. Because nobody has got a really good way of doing that today.
Wow, that's a lot of refrigerant seems pretty toxic, 1,000 times more than CO2. I did not realize that. Is there anything I can be doing to I mean I mean what can anyone at home be doing to try to solve and stem this problem, right? Is it just making sure that there's proper maintenance on these? What can I be doing?
Yeah, that's so proper maintenance is certainly part of it. But I would say that for most consumers and also for most businesses, I think that as there is more advanced equipment that's rolled out, initially price points are going to be higher. That'll almost definitely be something that needs to be dealt with. And historically, the cooling market has been very price sensitive. So it's opted for less efficient, lower cost equipment for upfront installation. I think we really need to have both consumers and businesses be okay with or figure out a way to deal with the fact that more advanced equipment that's ultimately better for the environment is simply more costly to produce upfront,
Hmm.
even if it's by an incremental amount that you save over the lifetime of that equipment. So one of the things that I'm really excited to see is the rise of a lot of kind of project finance mechanisms
Hmm.
that are allowing people to implement more advanced or even do retrofits for more advanced, more energy efficient equipment that they can finance with a third party, so they're not putting their money up front. And then we're getting more efficient equipment. The investors are getting paid back from some of that energy efficiency savings over time, and the consumer or the business upfront is not having to outlay their own money to do it. So it's kind of a win for everybody.
Gotcha.
I think
Sort of like
further
the
adoption
solar
of those.
panel
Exactly.
market and everything.
That's a
Okay.
form of it.
Gotcha.
Exactly.
Hmm.
Yeah. And people have learned a lot from how solar has been financed,
Hmm.
and are now deploying that into other areas. So I think the more that could be adopted, and the more that could be scaled both up for really big cooling applications like industrial power plants,
Yeah.
and down for really small applications like a residential home, and maybe made applicable in all those scenarios,
Hmm.
the faster we're going to get a solution to the cooling problem.
Gotcha. So, and I mean, so for me right now, um, the biggest impact I can have as far as making sure my AC doesn't suck is keeping an eye out for when new ones come on the market, making sure my current one stays properly maintained. Um, I guess just trying not to use it as much as like unless it's necessary, right?
Yeah, that. So all of those things, and then I'd also say, to the extent there is legislation that comes along that supports, at your local or at your state or even at a federal level, that supports financing for green energy projects or energy efficiency projects, or even just supports mandating improved or higher efficiency equipment, even if there's no financing for it initially. I
Hmm.
think we as individual voters and consumers should be supporting that. So showing support for that can be really helpful.
Hmm.
One example is that California is already putting into policy transitioning to basically 100% heat pump adoption. And just for reference, a heat pump is basically an air conditioner you can run in both directions, so you can use it to both heat and cool your
Hmm.
house, depending on whether it's the winter or the summer, and specifically electric heat pumps. So having these be 100% connected to the electrical grid, so that eventually all new home sales in California, or all new builds, will be 100% electric. There'll actually be no natural gas running to those residential homes.
That at least
The
limits
idea being
some
that,
of the. Sorry, the idea being
yeah,
that.
the idea being, if you can generate a bulk of your electricity from green production methods, wind or solar, and then pipe it directly to those homes, or put through wires directly to those homes, and then you've got all electrical appliances through the entire home, then you don't have to invest in the infrastructure for natural gas, and you've got a greener, end-to-end production consumption of energy. Ultimately, in the beginning, there's going to be a lot of those homes that are connected to the grid, which is ultimately power plants that are
Hmm.
producing that energy at first. But having a residential home that is 100% electrical versus any natural gas or other energy methods, it is the start to kind of pushing the market in that direction. So California is, and heat pumps are super, quite energy efficient,
Hmm.
on a relative basis to other kinds of appliances and other means you can use in your home.
Yeah.
So that's a really good step forward. And those kinds of programs are what the market needs on the supply side, I would say, are what air conditioner manufacturers, heat pump manufacturers need to see. They need to see that demand exists for them to invest upfront in making more advanced equipment.
Hmm.
So the more that you can get a policy pull, it does actually create an impact on industries like these. So we as individuals can support the generation of that policy.
Hmm. Nice. Okay. That's. I mean, that's super informative.
Good. I'm glad.
Thank you so much for coming on and explaining and making air conditioning exciting.
Sure thing. Thanks very much for having me on the call. I look forward to being on again soon.
Can't wait to have you. Big Feet is a production of The Impact and produced by me, Ian Sumner. Music is by Sarup Pujari. Check out our whole publication along with our other podcasts at readtheimpact.com. We'll be back next week.